Okay. Is that working? Oh, it says I'm live. It looks like it might be good. Oh, my screen. Looks like it might be good. I should probably turn that on, huh? You guys might want to see that, huh? Give me a second. It's been a while, okay? Display capture. Yes, create new. That one. Okay. Alright, that's looking good. Okay, you can see it. Great. Okay, everything's working. Awesome. That's all good. So, yeah, I'm gonna try this again. I have a tab open here on the OS Dev Wiki all about interrupts, and I'm going to be reading from that so that I can do some keyboard and timer interrupts instead of, just winging it. So, yeah, I'll see how that goes. So, I'm just going to start with a bootloader here. Wait. That's funny. What was it, DL? I think it was DL. Oh, wait. Yeah, it is DL. Okay. I don't know why it took me so long to find that. You know what? I'm gonna turn off codes suggestions for this. Let's see. Where can I do that here? Um. Hmm. There should be. Oh, is that it right there? I see. Code completions. Let's get rid of that. There we go. That's a lot better. Now we can be sure that this code is my own and not just generated by AI. Now, don't get me wrong. The AI is very helpful. I'm not denying that. But, it probably shouldn't be used for all programming tasks. Alright, let's see here. And then the stat can just go there. Gosh, what was the beginning of the BIOS data area? There we go. Memory map x86. Conventional memory is at offset 0hex7 and BFF. There we go. And then after that, there's not really too much we have to do. We just have to load the rest of the disk. I will have it print a message just confirming that we're doing this, though. There we go. And then I could do interrupts. I don't know if I'd like to do that though. Should I use BIOS interrupts? Nah. Wait a minute. Oh, wait. Hold on a minute. Alright, let's see if just that works. Oh, you know what I need to do? Pad the boot sector. Right here, and then right there. Alright, let's see. How do I do this here? I have a little thing open where I have like a whole build process and everything. Yep, just like that. And then there'll be other files in there when I actually make them. And then let's just do QEMU and then And I don't need MKFS. There it is. Oh, whoops. Oh wait, that's for later. I don't need to do that now. Jeez, I'm forgetting how to do all this stuff. Ah, right. And I think that's about it. That's all I had to do, yes. Alright. Oh, right. Okay, it booted. I must be missing something. You know what? I'm just gonna make a print function. That might have done it. There's no way. I figured. What's up with this function? I would rather just use EX here. That's just easier. Oh. Duh. That would do it. Jeez, And there we go. Jeez, Well, that's better. Alrighty then. Now I want to just load as many sectors as I can. It doesn't have to be pretty. I'm just going to put it all raw on the disk. No need for a file system for something like this. It's pretty simple. I've got a saved thing here of BIOS interrupt. It's pretty nice. Yeah, I could probably set pixel mode when I change, because it's still going to be in this. Okay. Oh, whoops. There we go. Right. The interrupt. Which one was the disk interrupt? It was... gosh, I think it was hex 10? No. It's 13, isn't it? No, not that. 13. Yeah, there we go. Read sectors. Alright then. I believe that's the maximum amount of sectors. It's way more than we need. Like 128 times 512. Yeah, that's exactly how much we can fit into one segment anyway. And then I think we can probably do that. And then yeah, there we go. And then I actually need to write something to there, so actually let's, there we go. Oh, right. ES offset BX is the load segment. There we go. That should do it. Something super duper simple just to start it off should be fine. And then and that should do it. I need to actually jump to it. I can probably get rid of the .done label. Ooh, you know what? I'm going to put a failure message. Uh, 160 is it? Yeah, that's it. Oh, you know what? There we go. Alright, that should be everything I need to do. Actually, to account for a real machine, just in case, I might as well do that thing that you need to do. Oh, whoops. Who needs labels anyway? There we go, that ought to do it. Actually, I might move the STI to after this tag. There we go. Alright, that should be everything. Let's see if it works. Oh, right, duh. I need to set that up. It's argument on QEMU. There we go. Oh, whoops. There we go. And... ooh. I must have done something wrong. I don't think I did. Let's see here. Ah, you know what I did? I need... there we go. That can still be CX though, because CH will be 0. But yeah, we want to start from the second sector, not the first one, because otherwise it would just be an infinite loop of doing this over and over again. Alright, that should be everything. Just that one little error. No, okay. Figured as much. Oh, how did that happen? Hmm. Ah, right. You know what? I might need the retries here. Um, yeah. Let's make a little function for loading from the disk as well. It can be super duper simple. Uh, I know how to spell. Whoops. Oh, whoops. Not disk node, drive node. Right. This is kind of a pain. It's probably also super inefficient, but oh well. It's like 10 instructions. I'm sure it'll be fine. Famous last words. Alright, I have the, yeah, I do. Okay, good. I probably don't need to do this, but whatever. Alright, let's see what we've got going here. Oh, right, I don't call it, do I? Hey, what's up, Ramder? How's it going? I haven't missed your chat for too long, have I? There's no timestamp or anything. Oh, let's see here. You know what? I'm going to... It probably doesn't matter, but better to do it than not. Right. Okay. I guess I can do this. And see if that changes anything. I don't know if it does, though. Hey, there we go. We got it. Hooray! Okay. So then let's just take this print and clear routine. These will be good for debugging, but later on I'm going to use what's it called? VGA text mode instead. No, wait, hold on. Instead of that, yes, there we go. And then what's the resolution of old VGA? No clue what I'm saying. This is 16-bit x86 assembly language. It's like super duper hardcore programming stuff, I guess. That's the best way to describe it. These are all just symbolic names for the raw binary that gets put through your CPU. So this is, each one of these is one thing your CPU does per one clock cycle. Now that dumbs it down a little bit. It's more complicated than that, but essentially that's what I'm doing. I'm going to make a print line function. And then just make a screen offset here. That's where we're starting off. And then let's get rid of that DI right there. Yeah. DI, word, screen offset. Yes. And then word. Not SI, DI. Okay. And I won't ever understand anyway. I mean, it's not that you can't understand it. I mean, I managed to understand assembly at least to a decent amount after, you know, a year and a half. It's not too bad, but You know, obviously not everyone will learn assembly language. Yeah, that'll probably work fine. I should probably put that at the end just to make sure everything actually loads, but I mean, more than 65 kilobytes in this program, I don't really see it happening. You never know, but hopefully not. Okay. Ooh, you know what? I forgot to set the other segment registers. Right. I believe that's all the segment registers taken care of. It's all the important ones anyway. Alright. Oh, you know what? Instead of doing that, there we go. That's probably a lot better, huh? Hey, there we go. Just wanted to make sure. Also, please feel free to let me know if I'm too loud. I can turn this down. Yes, okay. Everything has loaded now. I think the first thing I'm going to do is set it to pixel mode. Now, that's not to say I'm actually going to keep it in pixel mode. I'm going to just do that temporarily. BIOS video mode interrupt. I forgot exactly what it is. 10H. 10. Set video mode. Let's see here. Oh. I see. We can set 132 by 25 or 40 by 25 text modes. Interesting. I want the classic 256 color VGA pixel mode. Let's see here. This is... Look at this, real quick. This is, like, unreadable. I have no idea what any of this means. The top is pretty readable. Yeah, it makes perfect sense. You know what? There was this one repo I saw that said it. Let me look that up real quick. Come on, where is your bootloader? There it is. Okay. That's not at, Ah, there it is. Oh wait, I can't just do that, can I? Duh. No, I forgot the default VGA color palette. I should look that up. Default VGA 320 by 200, I believe it is. Yeah, it is. 320 by 200, 256 color palette. Oh, mode 13H right there. Awesome, awesome. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 16. Oh, I didn't finish that. I'll do that in a second. Alright, let's see how that works. Nothing. I see. Let's just fill up the whole thing, shall we? Oh, I need to keep SI at 0. There we go. What's 320 times 200? That is 64,000. There we go. Hey, alright, awesome. It is working. So I guess I just got VGA white off. Let's see here. 1, 2, 3, 4. I can't read that. 2, 3, 4, 5, 6. Maybe it's 14? It might be 14. Let's see. Well, that's certainly not it. Oh, that's because I made it 13 and not 14, probably. Ah, it's so close. Come on. Hey, there we go. I got it. Let's go. Let's not increment AL in the loop now. And then VGA white. Remove all that. And let's see if that fills the screen with white. It does. Let's go. I got it. Perfect. So now that we know that, I can go ahead and comment this stuff out. And then I can remove all of that. Okay, now I think I'm going to start with interrupt handling. I'm not 100% sure how I'm going to do that quite yet. I do know, first of all, that I need a PIC interrupt, so I can pull up my operating system's code, but it's not going to quite be the same because my operating system is 32-bit and I'm working with 16 bits. Let's see here. Time.c should be right at the bottom. Oh no, never mind. That's CMOS stuff. Init timer, there it is. Right, I need to set the frequency and all that jazz. Set timer right there. Okay, I need to get those constants. It's been a little while. Okay. Oh wait, those aren't macros. I'm so used to C's hashtag define. Oh, I need channel 2. Well, I don't actually need channel 2. I don't even have a PC speaker hooked up, but whatever. There we go. And then not that this matters because we're in 16-bit. There we go. Some good PIT definitions, and then I should probably get some NB and out B macros. Or we can just get the port. What was it? %1? I think that's what it was. Right, I'm pretty sure that's the syntax. There we go. Returns that value in AX. Oh, yeah, rather AL. Oh, I forgot exactly what the syntax I'm used to is, which is kind of funny. Right, the first one is the port. Assembly AI when? Oh, well, I would, but, you know, I don't have 300 years left in my life, so unfortunately I don't think I'll be able to complete that. But, you know, maybe someone more talented than me could do something like that. Also, you know, TPUs aren't CPUs. What was I thinking of? Right. That's misspelled. And then I don't think I need any in or outward macros right now. This should be fine. Alright, let's get to initializing the timer and some IRQs here. Oh, that's another macro I don't have yet. Wow, that was that was the only thing I was missing. Guess I located everything except for that one macro in my source code here. And then I need the divisor here. I can just divide it by 1000 to get 1000 ticks per second. And I mean, that's obviously fine. But it really only needs to be set to, what, 17 ticks per second? Can I just divide it by 17 to make it do that? I don't think so. Pretty sure there's a way to do that. Right. Let's see here. I think if I just divide that number by 17, I can get the, what's it called? The quotient, I think it is. And then send it out. 70,187. I don't know if that's right. I just divided it by 1000 over here and got it right. Ooh. I think I'll just set it to 1000 per second because there's nothing wrong with going beyond there. It's way easier to just set it to that anyway. So, x 1000. And then, wait, hold on. Oh, what was it? Hex FF. And then yes. PIT channel 0 AX. Oh, yeah, AX. Oh, wait. I don't have to do that, do I? I can just use AL. Duh. There we freaking go. one positive about using assembly, I guess. No fancy bit shifting needs to be done. And then, yep. That sets it, but I still need to make an IDT and all that crap. I believe that's what, hex 40? No, I think it's hex 20, if I remember correctly. Let's see here. Yeah, it's hex 20. Okay, I was right. Cool, cool. Yes, anything good here for figuring this out? This is 32-bit and 64-bit on the OSDev wiki. Great. Guess I'll just Google it. 16-bit x86 interrupts. Interrupt descriptor table on the OSDev wiki, but that's again just 32 bits, unfortunately. Real mode. No, nothing in there. Interrupt and exception handling on the x86 from MIT. Let's see what that's all about. x86 interrupt vectors. Yeah. That makes sense. I should probably reserve the whole interrupt stuff. I don't have anything yet. Yeah, the PIT IRQ is 0. That's 32-bit x86. Darn it. And then 16-bit MS-DOS programming. Why is there no documentation online? I can't believe this. No one writes documentation for 60-year-old processors anymore. Why even live? I wonder if the Intel Software Developers Manual has anything on it. I'll just pull it up. It's probably better than looking at nothing while you're doing stuff, right? Oh, I hope that didn't show anything. Yeah, that was an accident. Oops. It's all good. Phew. Don't worry about that. System programming guide. Interrupt and exception handling. Oh, this is IA32, right. Alright, let's see. What's this? Instruction set reference. That doesn't mean much. From 1999. Oof. First x86 software development manual from Retro Computing. Looks just like Stack Overflow. Like exactly like it. Oh, stackexchange.com. I see. 8086 Family Users Manual. There we go. Alright, let's take a look here. October 1979. Looks like... Whoa, no. That's not good. That's really not good. I might have to look for something else. This is... Oh, right. Forgot that there was this. Let's see here. Ah, right there. 2-22. Right there. Oh. Wait. Multibus architecture. External interrupts. Where does this go? Request/grant lines. Yes, of course. I see. Yeah. That's what I that's what I want right there. Oh my. Okay, any diagrams of... Oh. Ooh. 16 bits from here to here, and then these are what, offsets? Oh, these are... This is how an IDT looks, I see. Are they just pointers to interrupts? Oh, this is the IVT, I see. Oh, to the first 1K bytes of a low memory. So it has to be down there? I don't want to overwrite BIOS interrupts, but do I need them? I'm probably going to be replacing them. But if you think about it, right, DOS, I believe, lets you use the BIOS. I don't know. I haven't done too much assembly programming in MS-DOS. I've done a little teeny tiny bit, and I'm pretty sure I used one or two BIOS interrupts, but I can't quite remember. I see. So then, if I had to assume, I can just Mint. Yes, this is Linux Mint. Right. So I guess I should make a function here that says make interrupts. Sure. Dude, you are so underrated. Well, thank you. I appreciate that. I just like making programs, really. I thought, low-level programming like this was pretty interesting, so I decided to just record it. So the first 1 kilobyte of a low memory. Alright, and it's just pointers, right? Let me go back to that here. Yeah, it's just 16. Oh, I see. So it's technically 32 bits. It's the CS base address and then the instruction pointer offset. So it's just regular segment offset pointers. Okay, okay, that's fine. The low word is the instruction pointer offset. So let's just say, I don't know, interrupt 0x30. Move AX. Let's see if that works at all. And then move AX 0x30 and move BX. What was it? 2? Because it's 2 words. I thought x86 was 32-bit. So x86 has been around since like the mid 70s, and the first x86 CPU, the 8086 processor, well, the first true x86 CPU was the 8086 processor, and that was 16-bit with a segmented memory model like what I'm programming here. And most x86 processors, well, actually all of them, still support 16-bit mode. Like when you press the power button on your computer, the processor starts out in 16-bit mode, and it's either your BIOS if you have UEFI or your operating system that brings it up to 32 or 64-bit. Is it 2? No, it's 4 because it's D words. That should be the offset. What was this here? Oh wait, no, the low word was the offset. Invalid 16-bit effective address. Does that work? No. Oh, wait, you know what? I have an idea. Oh! Yeah, there we go. Yeah, that's better. Very interesting. Yeah, it is pretty interesting. x86 CPU architecture is pretty interesting. It's got a pretty storied history. And it's kind of funny how x86's backwards compatibility actually led to the death of Intel's Itanium architecture. It's so cool. I don't understand anything of your code. Yeah, I mean, x86 assembly can be pretty hard to read. And, you know, obviously, as you can see by all of the comments I've made, I've tried to make it as readable as possible. Obviously. Two. I mean, I come from C# and Python. I mean, hey, you know what? I started out with that too, actually. At the place I work, my job, I actually do automations in C#. And I do know a little bit of Python. I used to know way more about Python, but I don't ever program in it anymore. So, you know, I'm not super well versed in it. Right. So I would probably want to clear interrupts and then put that in there and then re-enable them. Now, is that all I need to do? Surely not. I guess I can try it. Alright, let's see. It's probably gonna... Oh? Let's see. Yeah, I figured as much. Not quite it. Let's go back to the BIOS interrupts table here. Wow, there's a lot of them. Okay, so 30 is already taken. Oh, not a vector. Never mind. It's a DOS interrupt, but I don't use that. I am bare metal programming. So if it's not a vector, I guess I'm doing something wrong. Okay, well, what if I did, what if I just did that? No, I need an IDD pointer, obviously. What am I thinking? Ah, gosh. It's been a really long time since I did interrupts, okay? And I took so much of the code from somewhere else. I just could not understand interrupts for the life of me for such a long time. Let's see here. Yeah, this is just the interrupt pointer table. So that just does a whole bunch of interrupt pointers. Interrupts. Maximum mode. Very interesting. I've never heard of that. I should probably keep this on here when I'm spending a billion years reading it. And then there's that. Interrupt priorities. I don't need that. Yeah. I should keep that in mind, I guess. That is not a interrupt thing. Wow, this documentation is kind of ass. Interrupt requests. Yeah, I'm gonna have to look up something else. Hmm. Oh, you know what? Real quick, I'm just gonna define some stuff for the keyboard. I'll come back to interrupts. I don't want to spend a trillion years working on that. I might do that in my own time or something. Let's go over to keyboard here. Okay. Oh, that's not the read register. There we go. Oh, wait a minute. What is it? I need to knot this bit away. There we go. And then I don't need a super advanced driver. This is just a little game. And it's meant specifically, basically for like IBM PS2 PCs. So I think that's all I need. Now I just need some scan codes. So I'm going to want W and S. Hex 1F. And then up and down arrows. Hex 48. Oh, whoops. I hate it when that keeps showing up. Like, I've not used that once. I don't want to use it. That's not what I'm trying to do. Up. Hex 48. There we go. And then let's get rid of that for now. And then let's just wait for the W key to be pressed. this wrong? Ah. Right, because destination source. Right, obviously. The trick is to write 16-bit code twice to get 32-bit. I mean, that's basically how 32-bit works. It's just 16-bit, except there's 16 more bits. Like, you would not believe the... Well, I mean, you might, but you would not believe the amount of workarounds that Intel did for x86. Like, it was 16-bit, and then 16-bit but with more memory space, and then 16-bit with even more memory space, and then they just gave up and did 32-bit, because it's like, well, we have so many workarounds. Like, I think people might just want 32-bit CPUs at this point. Oh, that needs that. There we go. Alright, now let's see if that loop works. It does not. That's unfortunate. Here, let me look at my old repo real quick of my thingy here. There it is. Because I got keyboard input on that one. I see. I actually have to enable the keyboard. Yeah, that would that would do it, huh? Forgot about that. Let's see here. Initialize keyboard. Oh, that's a whole bunch of extra crap I don't need to do. Never mind, I'm not using my operating system for this one. Let's just put it up in here. No need to be all serious about it. It's like 3 lines of code. All right. There we go. And then that should do it. Let's see here. Boo. What else am I missing here? I can probably just do it like that, honestly. Alrighty then. So what's with that stuff? Key. Get key. Where is my get key function? Oh, check keyboard. There it is. Enter. Oh, it's right there. Oh, interesting. Interesting. Okay. That's probably a little better. Let's see if that works. No, it doesn't. hex 7. Interesting. I wonder if the value changed. It most likely did. But I'm 99% sure that that's the W key. What am I missing here? Where are all of my macros in this? Where did all those macros go? They must be near the bottom. Yes, they are. That was it, right? Yes. Okay. So then output full equals 1, really? And then input full equals 2. I see. Well, you know what? Let's have it be pressing any key just to see if that even works. Test AL1. There we go. Huh, that's weird. I'm doing something wrong, clearly. What have I done? Okay. That's fine. Okay, yeah, that makes sense. And then just 0. Jump if greater than. Let's see. Still? What is going on? Man. What's that one BIOS interrupt that makes you wait until a key press? $16H or 22H. Oh, or just 22 actually. Get keystroke. Oh, there is check for keystroke. So I can just use the BIOS for this. Holy moly. Okay. So then, move AL0x1. And then int hex 16. and then jump if not 0 dot done. Let's see how that works. I'm starting to feel like something's wrong. What if I just get rid of all of that and have it just print the line? I wonder how much of my code actually worked. Why doesn't this work? What's up with that? I do set the segments, right? Yeah. So, why isn't this working? Uh-huh. Yeah, that's pretty weird. I mean, I'm glad I discovered this BIOS interrupt so that I don't actually have to make my own driver or anything. Oh, you know what? I wonder if it's the, my messing with the hardware. That might do it. Let's not do that instead. Why am I pushing AX here? I forgot why I'm doing this. Well, that's leaving too. Let's see how just that does. Uh-huh. I mean, clearly all of this is being loaded, so what's the deal? I mean, we can just do that, I guess. Okay. Okay. Something must be wrong with my print line function, I guess? But what's the deal with that? I mean, it looks fine. It worked for the rest of this. And then it's just that for the screen offset. What the hell? Let's see here. Okay. Oh. Wait. Okay, that's what it should be. Yeah, this should all be fine. It's just exactly like my other implementation, except for GS, I guess? I mean, I guess we can try GS instead. Huh? No instruction. You can't push GS on the 186, on the 8186, really? Or the 286? That's crazy. The 386 was the first processor to allow pushing GS. That's crazy. Not like it mattered. Huh. Yeah, I don't know about that. Let's try 686 and see if that changes anything. Yeah, that's pretty weird. Oh, wait a minute. It's not even loading this anymore? Hold on a second. What's going on there? Okay. I'd like to have this support 8086. Because I think that would just be cool. Okay. I mean, DS doesn't change though, does it? Nope, it's exactly what it should be. Yeah, I have no idea why it's doing this. It should print this to the screen. I mean, maybe it's just because of the string's location, maybe? Let's try that. Yeah, I mean, maybe. And I do say 8. Oh! Oh my god, I'm dumb. That needs to be AH. That would do it. Oh my gosh. Yeah, let's see here. Let's look at that interrupt now. AH equals BIOS scan code and AL equals ASCII character. Oh, so it returns the ASCII character. I don't even really need the scan codes. I don't know what BIOS scan code is. I wonder if it's maybe just like PS2, but I don't know. Can't be sure. Compare AL W and then jump if equal. Alright, let's see. Moment of truth. Gosh darn it. Maybe it needs to be uppercase. No. Oh wait, wrong one. I see. Maybe this isn't like supported or something. Let's go for get keystroke. Oh, wait a minute. I think I might be stupid. Because that's what I need to do. And then that needs to be lowercase again, I'd assume. Wow. What do you know? It was that easy. I was just being dumb. Okay. That is honestly great. I'm glad we can just use the BIOS interrupt for that to check. That saves me a lot of time and effort. And I think this is what I did. No, this isn't what I did last time. What am I talking about? I used, what's it called? Okay, I'm gonna let my dog into the room real quick. She's scratching at the door. Alright. So, now that that's working, it's pretty late where I am. So I think I am going to call it here. I made a lot of progress in one day, though. Like, imagine. Well, I guess you don't have to imagine, but if you look back at when I first tried this the first time, progress was definitely way slower than this. And I didn't use the help of AI this time, and I'm really proud of that. I want to lean away from using AI for everything in programming because it's you know you probably shouldn't be doing that. And yeah, that'll do it this time. But yeah, I'm really glad that I made the progress that I did. Uh, I'm pretty satisfied with where I am now. And next time, I'm probably going to work on timers and some game logic. Uh, you know what? Before I do that, though, well, before I leave off the stream, I'm going to check and see if there is a BIOS time interrupt. A BIOS timer interrupt. Let's see here. And 8H. Okay, interrupt 8. Let's take a look. IRQ0 system timer. Okay. 8286 plus is a double fault, though. Is there another one? BIOS interrupt call. 18.2 times per second. The BIOS increments the time of day timer, or time of day counter during this interrupt. Okay. Is there anything else that I can do with that? Oh, real-time clock, RTC services, 1AH. That's real-time date, or real-time clock services. I don't know if I want that, though. I guess I can look at it. Which one is it? 1AH. 1A, there it is. Time, get real-time clock time. Okay, is that in seconds? I assume not. Let's check out get system time. Number of clock ticks since midnight. CX offset DX. Really, it only needs to be 32-bit, huh? I guess 4 billion seconds. that does make sense. All right. Yeah, I'll see what I can do with that next time. But I think I'm going to end this stream for now. But yeah, I made a decent amount of progress, I think. And yeah, I'll come back to this soon, hopefully. No promises, though. We all know what happened last time. All right.